Everyone, and welcome to day 2. More on continuity. And so, again, the definition, the function is said to be continuous following the conditions are satisfied. Those conditions, and let's work here. Those conditions are the fact that the limit as x approaches a of f of x exists, that f of a is defined, and that the limit as x approaches a of f of x equals f of a. And we've talked about that before, so that's not a surprise to you guys. The theorem, just so you guys know, polynomials are continuous everywhere, and therefore the limit does exist at every point. We know that if two polynomials are added together, they're continuous. If they're subtracted, still continuous. If multiplied, still continuous. If divided, as long as g of c is not equal to 0, it's still continuous. A rational function is continuous at every number that's not 0. We have already said this too. The absolute value of a continuous function is continuous. We've got a definition here. As long as it's continuous on the closed interval, we know it's continuous everywhere. If f is continuous from the right at A and is continuous from the left at B. That's kind of key here, that if we're looking solely at the left and right due to the fact that A and B are at the interval here, that's the endpoints, it's continuous from the right and continuous from the left. Not the opposite, of course, because there's nothing there. So just make sure you realize that, like if we got here to here, it's definitely not continuous at A from the left, but it is continuous starting from the right. So prove this. This is a really easy example. I want you guys to understand that this is not meant to be too difficult. So we want to prove it's continuous at -2. So we need to find the limit as x approaches -2 of f of x. Well, guys, this is a polynomial. All you're going to do is plug in. No factoring, no multiplying by the conjugate, nothing other than plug in. 5 times -2 cubed. Okay, let's try this again. Cubed. And we know that's -8, so that's -40. So that's condition 1. Condition 2 is that f of -2 must exist. And what is that? Well, we also know it's 5 times -2. That's why I said it wasn't a huge problem. It's a polynomial, so therefore we knew it was continuous, so that's why these two are continuous here, or are the same. And we said that -40 has to equal -40, and that's also true. So since the limit exists, the function's defined, we know what those actual values are, that they're equal, it's continuous. Done, that's it. That's all you need. Okay, second page. So page 2, we're looking at proving that it's not continuous. One of the things to know that not continuous means that all you have to do is prove one of those 3 parts of what it means to be continuous to be incorrect. You don't need to prove all 3. Okay, just one. To prove that it is continuous, you do need to make sure that you've gotten all 3 correct. But to prove that it is not continuous, just one. Well, all we're going to do is f of 3. F of 3. When we do that, you're going to get 0 over 0. I know it's indeterminate form. I understand that. It's indeterminate. But here's the thing. When you have 0 in the denominator, you know the function, that f of 3, is not defined. That's all you need to know. If f of 3 is not defined, you've just proven that f of x is not continuous at x equals 3. That's it. Because you've taken one of the necessary steps and proven that that is not correct. So, done, over, move on. Is f of x continuous here? Well, what we need to do is we have to take the limit. We notice that we have a piecewise function. Is f of x continuous, period? Well, we know that any value is less than 4, yes, it's continuous, it's polynomial. Any value is greater than 4, yes, continuous, it's a linear function. So what we need to prove is it continuous at x equals 4? So we've got to find the limit as x approaches 4 from the left. This is less than, so that's for the left. And we know that we're just going to get 4 squared to get 16. Now we need to prove the limit as x approaches 4 from the right. We need a greater than. And that's going to give you 20 minus 4. That gives you 16. So we know the limit as x approaches 4 of f of x equals 16. Oh my goodness, guys, sorry, my poor skills here. 16. What we also need to prove is what f of 4 is. Well, we see it's equal to 4 right there, and so therefore we get 16. And the 16 equals 16, and therefore, yes, f of x is continuous. Now looking over here, I'll change colors. Looking over here is a continuous. Yes, polynomial. Yes, linear function, so we're good. We need to prove that it's continuous at x equals 1. That's the goal here. So we're going to go limit as x approaches 1 from the left of f of x. That's looking at 1. So we got to look at the limit as x approaches 1. Let's try that again, 1. 1 from the right of f of x. Well, 1 from the right is 1 minus 2, which equals negative 1. And therefore, the limit as x approaches 1, if they're not equal, of f of x, does not exist, and therefore you're done. F of x is not continuous. Okay? And done. You did it. It's not continuous at 1, but it's not continuous in general. It's definitely not continuous at 1, though, because the limit does not exist. Okay? So, last two here. Notice here that you know it does not exist at 2. We know that because we can cancel those out. So it's asking you what value of k is it to make it continuous at 2. So basically we have a hole, and you need to figure out where that hole is, the y value, the value of that function at 2, to plug it and make it a continuous function. So what are we going to do? We're going to do the limit as x approaches 2 of f of x, and that equals 2 minus 3, which equals negative 1. So therefore, f of 2 equals k. Knowing that, that implies that, let's try that again. That implies that negative 1 has to equal k, since the limit as x approaches 2 equals f of 2, and we know that negative 1 equals k, and so therefore that's why we get negative 1 to equal k. For our last example here, we have another piecewise function. We've got 2x plus 12k squared, that's a polynomial. Then we have a trig function. And so immediately we're going to look at two things here. We're going to look at the limit and from both the left and the right. The easier one, of course, is the limit as x approaches 0 from the left. And this is going to be a little bit of a longer one, so you may want to leave yourself room or write small here, of f of x. And so we know that equals 2 times 0 plus 12k squared. Well, what's that? That's just 12k squared. So that's the limit. That's all we know. We're trying to find k. We also know that for it to be continuous, we better have the limit as x approaches 0 from the left or right. And so with this, we need to find f of x, which equals the limit as x approaches 0 of 5 times sine kx over x. All I did was take the 5 out. I could bring the 5 out in front, that's fine too. That also, we now need to split it up, and we need to use the theorem here. The theorem that we know, sine kx over kx, the limit as x approaches 0, we need to use that. So we need to multiply by k over k. Why? We have kx here. We need to get the kx in the denominator. This k can come out here. So we're going to get the limit as x approaches 0 of 5k multiply the limit as x approaches 0 of sine kx over kx. And we know that that all goes to 1. Not 0, but 1. And then we have the limit as x approaches 0 of 5k. Well, x going to 0 is not k going to 0. So that is just going to equal 5k. So therefore, we know then the limit as x approaches 0 from the left is 12k, from the right is 5k. We know that then, the limit from the left, has to equal the limit as x approaches 0 from the right, which then implies then that 12k squared has to equal 5k. The limit from the left has to be the limit from the right to be the limit. So then we know that if that's true, that we set them equal, we have to solve for k then. So that implies that 12k squared has minus 5k has to equal 0. And then we can factor a k out and get 12k minus 5 equals 0. And you're going to get k to equal 0 and k to equal 5 over 12. Please, please, please do not divide by k right here, right there. Divide by k and lose it. You cannot divide if it's set equal to 0. Please do not do that. You must factor. So our final answer is k equals 0 and k equals 5 over 12. You can go back up here and make sure that when you plug in k, it works. It does work. Notice that we're not dividing by 0 because it does not equal 0 in this one. So if you need to go back and rewatch that, please do. The joke of the day: why did I divide sine by tan? Ready? Just 'cause. See you guys in class.